In our first video segment, we looked at the difference in output waveform stability between the VPI SDS power supply and the Phoenix Falcon power supply. Because the SDS uses a PLL circuit, the waveform wobbled excessively when switching between 33 and 45 RPM. Once on speed, the waveform appears to be stable, but because of the PLL circuit, it is still wobbling and not as stable as the Falcon power supply output. This is a reference signal used by the SDS power supply to generate the 60 Hz output as seen on an RF spectrum analyzer. The output is settled at 60 Hz, but from the analyzer display we can see that it is not a steady tone, but is being modulated by a number of frequencies. The 60 Hz waveform that drives the motor will also be varying at the same rate. The wide skirts on the spectrum analyzer also indicate a lot of phase noise present on the output. This is a reference signal of the Falcon power supply displayed at the same resolution. As shown by the single unwavering peak, the output is rock solid and does not wobble like the output of the SDS. The sharp skirts on the display indicate very low phase noise. If we listen to the demodulated output of the SDS reference signal on a communications monitor, you can hear the variations in its frequency. The same variation is present on the output that drives the turntable motor. If we listen to the Falcon reference signal on the monitor, you can hear that there is no variation in frequency, so the turntable motor will be driven by a much more stable source. The purpose of a synthesized power supply is to provide a stable 60 Hz drive voltage for the turntable motor, free of frequency variations and noise that are present on the AC power that comes from a typical wall outlet. The cleaner the drive voltage, the more stable the motor speed and the lower the vibration will be coming from the motor.